Every once in a while in our math course, they give us something that's really easy or makes a difficult process easy. And one of the things I found that students find difficult is long division of a binomial into a trinomial. But we do have a process to make division easier, and this is called synthetic division. Now, if you look at the textbook, they tend to make it a little complicated, and I think what my job is to make it a little easier for you. So let's look at it here. Again, I think they're making it difficult. So let's look at the process of synthetic division. Now, the key to it is, in order to use synthetic division, it has to be in the form x minus k is what this book is using. Other books use x minus c, where c is a constant, k is a constant. So if it's in this form, we're able to use synthetic division. So we'll get back to this in a moment. But this is the example they're giving us if we're doing this in long division form. Now, in order to do this, there is a certain process. Now, here again, it's a little bit confusing. So we're going to skip this example and get right to the real examples. But we'll get back to our x minus c or x minus k in a moment here. Now, they're going through it in very great detail, but I think that's confusing. So here we're going to finally start using synthetic division to do a problem. And here again, it's somewhat confusing, but we'll try to make it better. So here's our big numerator, and this is our denominator. Now we want to put our denominator in the form of x minus c, so we can find out our value of c or k, either one. Now, if we had x plus 2, and what would be the value of 2 if we're in this form, x minus k, or c, makes no difference. Well, it would be x. In order to get a positive there, watch this. K would have had to have been a negative. So, again, we want, our basic form is k, x minus k, or x minus c. In order to get a positive there, what would have been our value of k? Because there's a negative in the formula. And the key is, it's the opposite sign of this. So here they're showing you how it works. So what is your constant then? Your constant is a negative 2 to fit in this formula to become a positive 2. So it's the opposite of a negative here, makes it a positive. But what was your original c or k? Makes no difference. It's a opposite sign of this, a negative 2. So this is how we're going to start. Negative 2, and we usually do it this way here. and I'm going to make my upside down division sign. So normally it would be up here. I'm using it this way. And again, the author uses a little different technique. There is a video of it if you'd like to see it. And now we're going to copy this down. And what we do in synthetic division, once it's in descending order, and it's to the third, the second, the first, to the 0 power, that's in descending order. We just take the numerical coefficients of these numbers. So a 5, a -6, a -28, and a -2. Now the rule is we put now another line like so underneath. And the first thing we do is just bring down our 5 all the way down here. And what we often do is put an arrow right there to indicate we just bring our 5 down. Now we then multiply our -2 times 5 and get a -10. Now here we don't have to change signs or anything, we just add. This becomes a -16. We then take a -2 times a -16 and get a +32. And again, we don't have to change signs, we just add. This becomes a +4. Then we take our -2 times a +4 and we get a -8. My wife is calling me a little bit. We get a -10. So this is actually our answer. Now if we wanted to display this as a result of this division, what would we put here? Well, we would put, and the basic rules for this is, what was the degree of our original term up here in the numerator? Well, it was a 3. So we make this an x to 1 degree less to the second. This one, 1 degree less, x to the first, plus 4. And our remainder now is a -10 over the original form of it, which was x plus 2. And this would be our synthetic division of example 1 up here. Now again, they're showing all of this in great detail and using a little different system, whatever system you use, and again you can watch the authors, this would be very useful. Now the advantage of having a video is you can see it all in one step. And then your final answer, as we said, was this. And this is your remainder. Now another way you could have written this, instead of putting the negative by the 10, you could put the negative instead of that positive there. And that would be the same. Okay. And another way of writing it is if you wanted to prove it by multiplication, you could multiply this binomial by this trinomial, that's what they're showing you here, and then eventually add a -10 to it. Okay, so hopefully we've cut this down a lot, and we'll do another one here shortly. Again, the textbook's a little wordy here. And that's fine, because as they get paid to do this, but we want to try to make it a little easier for you. So what we're saying is if you take your binomial, multiply it by your answer, and then add your remainder, you get your original. So they're defining these parts here. And this gives us to a special theorem that we're going to introduce, and that's called evaluating polynomial functions using the remainder theorem. Okay? So let's take a look at this. Now, they're saying if you have a polynomial and you divide it by, again, in the form of x minus c or x minus k, that's the same, then the remainder is equal to k. All right, well, let's take a look at what they want. So here, if you plug in, and let's take a look at this, and we're still working with the example we gave you earlier, that when we did all of this, we ended up with a negative 10 as a remainder. Well, what was our C value originally here? Now remember, the C value originally was a negative 2. So again, opposite sign. Because of x minus k, it was x plus 2. So our k, or our constant, is a negative 2. So f of negative 2 into our function. As we do all of this calculation, we end up with a negative 10. And this shows that special use of the remainder theorem. And again, you're going to have to try this in your practice and your quiz-mes. And we saw once again when we did the synthetic division, our remainder was a negative 10. So let's apply the remainder theorem. And now here they're not giving you a true divisor out here, but they're saying f of x is a negative 3. And let me show you, they're showing it to us here too, that right here they're saying originally it would have been this, x plus 3. So our value then is a negative 3, opposite sign. So that's what we put here into our expression. Now, an interesting thing as we look at this one, what is our coefficient of this term? It's a negative 1. What's our coefficient of x to the third, which is missing? Well, that's going to be a 0. But we have to put it there to occupy the various degrees as we go from the fourth to 0. Now, the second degree is there, so its coefficient is 3. This is negative 4, and this is negative 5. So once again, we just move the 1 down, and you can have the line underneath or over, however you want. And you could put a little line there if you want, or whatever technique you use. This just goes down. Then negative 3 times negative 1 is positive 3. Now you have a place to put it because you put this 0 there. That adds up to 3. Negative 3 times 3 is negative 9. Add these up, you get a negative 6. Negative 3 times negative 6 is a positive 18. Add these up and you get a 14. Negative 3 times 14 is a negative 42. Add these up and it's negative 47. So our results then, and again we're using the technique of synthetic division to do this, and then just modifying it a little bit from our original divisor here. If it's a plus 3, we put a negative 3 in there. That's going to be our f value here. And then when we do so, our end result is a negative 47. Very nice. Now, one of the big topics we'll be dealing with a little later, and in a sense starting now, is testing potential zeros. And this is sometimes later referred to as finding the zeros. And I'm going to give you a little background on this. Now, this is coming up later, but something you may want to have an idea what they're talking about. So let's say in the future you sometimes get one of these cubic or to the fourth degree things, and it looks like this. And we've taken a portion of it. Now notice it's crossing the x-axis right there, and right there. Now, what is the value of y when this graph crosses the x-axis? What is our value of y right there? Well, it's 0. So, when we are saying testing potential zeros, what we're asking you to do is to figure out where would this graph, if it were plotted, cross the x-axis where y is 0. Remember, our value of y there is 0. So we are finding the zeros. So this one would be, for instance, that 0 would be a -3. This 0 would be a 1. This one would be a 5. Now these are all ordered pairs, so we would just add a 0 for our y element there. And this is what we call finding the zeros. Now, how do we know what these will be? Well, they're going to give us a value for x, and we're going to put that into our equation. If the remainder, when we do that, is 0, we have found a 0. It's kind of fun. It's like a little scavenger hunt here, but with algebra. All right, so let's take a look at an actual example. So in the first one, we're saying that our constant of this function is a 1. So we're going to use synthetic division, putting our expression into the format to do synthetic division by just putting the coefficients of each of the terms and then working it through, and then you find out that you have a remainder of 0. You have found a 0. And this first one, k equals 1, is a 0, and the ordered pair of that would be 1, 0. It's an x-intercept. Now let's do the next one. Here we're going to use a -1. Now we put a -1 in there. Again, in this value, notice there is no x to the third. So we had to put that 0 there, but we're going to use a -1 now. And we run it through synthetic division, and we end up with a 6. Since we ended up with a 6 and not a 0, is this going to be one of your finding the 0 answers? Well, we didn't find a 0 here. So this is not a point. That is a x-intercept. We didn't find the 0 there. In fact, on the first graph, this is where it is. And then on the second graph, it's up here. So it's not down there where the lines are. Okay, now this third one is rather tricky. And in fact, I looked at the author's video of this to see how it was done. And this is a rather unique use of synthetic division, where this was the original. Okay, we kind of spread it out here a little bit because we have to put some I values in. And in fact, let's watch the author's treatment of this. Now I'm joining the author partway through where he worked out the previous two examples, and he does a nice job too. So keep in mind this is a reference available. But let's hear him do the last one.
Decide whether the given number k is a zero of f of x, where f of x is equal to x to the fourth minus 2x cubed plus 4x squared plus 2x minus 5, and k is equal to 1 plus 2i. So we're interested in finding out if 1 plus 2i is a zero of this f of x. Once we'll use synthetic division, and so we need to write down the coefficients of the function. So we have 1, the minus 2, the 4, the positive 2, and the negative 5. We're going to divide that by 1 plus 2i. So to begin, we bring down the 1. We multiply the 1 times 1 plus 2i. We add together negative 2 plus 1 plus 2i, that's negative 1 plus 2i. Now we multiply negative 1 plus 2i times positive 1 plus 2i, and you'll notice that the final result of that is a negative 5. We add 4 and negative 5 for negative 1. We multiply the negative 1 times the 1 plus 2i, which gives us negative 1 minus 2i. We now add 2 plus the negative 1 minus 2i. The result is 1 minus 2i. We now multiply 1 minus 2i times 1 plus 2i, and this time the result is the real number 5. Negative 5 plus 5 is 0. Since the remainder is 0, that tells us that 1 plus 2i is a zero of f of x. 1 plus 2i, of course, is not a real number. Therefore, it does not appear as an x-intercept on the graph of f of x.
They show us all the steps here. And again, whether you know how to multiply imaginary numbers by FOIL, here it explains how to get a negative 5 out of this combination. That may be some background work you need to do. And keep in mind that, again, it's not a real number. It is a 0, but it's not on the x-axis. And our textbook, I believe, will show us that in the graph. Let me go back here. Well, they don't have a graph of that, but in a case of imaginary numbers, the graph itself does not go down to the x-axis. That's what makes it imaginary. Okay, lots of stuff going on here. Again, a good tool, and you'll need to hone your skill of synthetic division. And keep in mind, the booklet, our book has videos to help you on this as well. Okay.